Hello friends, Jai Shri Ram. Have you ever seen a three-dimensional movie? I'm sure many of you must have seen. An excellent example would be Avatar Water Kingdom. The 3D effects were really good. So in Avatar Water Kingdom, or maybe in the Dragon Slayer animated movie, you will notice that in the cinema theater, you are given specs. And when you take the specs off, then the entire screen is actually blurry. You are not able to make out anything. But as soon as you put the specs on, you start seeing all the objects in three dimensions. And isn't that fascinating? So, for those of you who want to know how this really works, what is the science behind it, this video is just for you. And within 10 minutes, I'd like to explain everything about 3D, everything that you need to know about. Unless we have two eyes and both of them are looking in the same direction, you cannot get the depth perception. How do you get the depth perception? Because there are two different images formed by two different eyes, and movement, size, and shading on the object is different for different eyes. For example, if something is approaching this eye, then this eye is able to get it, but this eye will only see the size difference. Got the idea? So we know in 3D how is it moving based on two images. If it is only one image, then I'll only see that object is growing. So I will not come to know whether it is approaching me or this is just growing at its own place. I just don't have an idea. I need to have a different perspective. Then I come to know about it. Got the idea? So this is how a human eye works. And this is what we need to happen when we are showing a 3D movie to the audience. The audience should be able to see the movie in the same way in which our human eye works normally. So the idea which is implemented is this kind of cameras are used to shoot the 3D movie. Every 3D movie has specialized cameras, and the entire shooting is different for that movie. There are always two cameras involved, and their spacing is usually the same amount of distance as the distance that is there between the two eyes of human beings. So usually that much of distance is there. So now, instead of seeing it through one lens, we are seeing it through two different lenses, and two different images will get captured. So basically you are seeing two different movies, but both the movies are playing at the same time. Okay, now what is done is we have something called as persistence of vision. That means if I show you 60 frames in 1 second, then you will assume that something is free flowing. There is no difference between the frames. If I show you one frame, cut, another frame, cut, another frame, cut, and if the frequency of these frames is like 60 frames per second, then you will feel like, oh, the frames are never getting cut. You are continuously seeing it. And this is the whole concept of motion pictures. So motion pictures is just like this, you have one image and then slightly different image, after that slightly different image. So these are called frames. So 60 frames per second is a very lucid kind of a cinema. Okay. Now, in this case, we have 60 frames shot by one camera, 60 frames shot by another camera, and both of them are shooting at the same time. So it's the same object being shot from two different perspectives. So total, there are 120 frames per second. Okay. Now you can cut it down. It will be a little choppy, but if you can very well cut it down, you can make it 60 frames per second. This camera shooting at 30 frames per second, this camera by 30 frames per second, and you will mix and match them to make it 60 frames per second. Okay, so this is how a film is shown on the screen. But then you notice that these are two different images from two different perspectives. So when you take off the specs, you see the same character, but you see two different images of the character. It's like this overlapping. Okay, now how do you see it as one image? Now for that, you have to be shown one image first through this eye, and the other image should be shown through this eye. The first image should not be seen by the second eye, and the second image should not be seen by the first eye. Okay, so it is a little tricky. How would you do that? So for doing that, you use glasses. Okay, those glasses are either red and cyan color or red and blue color. You can say red blue glasses you are there having, right? Either they use those kind of glasses, or they use polarized glass, or they use a shutter glass. So that is called as active 3D. So let us come to the next slide. These are the three different types of 3Ds that are available. The first two are called as passive 3D because your glasses are passive, they don't do much. For example, if you have a red cyan glass, then yeah, that's the color of the lenses on this eye and this eye. One is red, another is blue, or you can call it cyan. Those glasses are not doing much, right? They are just of that color, that's it. Now, the way that movie is made is that when you are shooting through this lens, whatever footage you got through this lens, you will be giving a red hue to it, okay, in the post production. And whatever is shot through the other lens, you give a blue tint to it or blue hue to it in the post production. Post production means you have shot the movie and after that you're changing the footage. So in post production, one footage is made red and another footage is made blue. Now when they mix together, you see the whole image, okay, and both these red and blue, they get cancelled out and you're able to see an image nearly in white color without any problem. Okay, so this is what is the concept. Now the problem with this approach is that the colors have to be modified a bit. You, in the post production, what you're doing is you're adding a hue to it, and that distorts the colors. You know, you don't get true color in red cyan glasses kind of a 3D. So if you're using passive 3D using red cyan glasses, then you don't see the colors very well. Now instead of saying such a big thing that passive 3D using red cyan glasses, I can use a single word for it, and that word is called as anaglyph 3D. So anaglyph 3D is this kind of a 3D. Okay, got the idea? Another type of 3D is polarized 3D. In polarized 3D, what is done is whatever is shot through this camera, that is shown to you using vertically polarized light, and whatever is shot through this camera is shown to you by horizontally polarized light. And you know that there are polarized films that are available, so that film allows light from in one direction only. So if the orientation of the light is like this, then only it will pass. And if you hold it like this, if you just turn it by 90 degrees, then it will start allowing a light which is polarized in this direction. Got the idea? So you have the same film, but 90 degrees apart like this. It is rotated 90 degrees. The polarization film is 90 degrees like this, and so this eye is only seeing that film which is having this orientation, and this eye is only seeing that film which has this orientation. Got the idea? So whatever is shot through this camera is polarized in a vertical direction, and whatever is shot through this camera is polarized in horizontal direction. And you just have to take wear the glasses, and you're able to see the screen properly. And since both the eyes are perceiving two different images and they are getting processed in the same brain, you get the 3D effect again. So this is a very, very cost effective and a nice way of polarizing or implementing 3D. So polarized 3D is usually used in theaters because you have to give a lot of glasses, and those glasses have to be cheap. Polarized glasses are not very cheap, but still they are not very costly. They are not as costly as shutter 3D glasses are. So these are cost effective and they are usually used in theaters. But then some people also have 3D televisions. So 3D television means what? The television itself is 3D, so it shows two different images. Okay, so then in a 3D television, how are you able to see it through your eyes? So they use a different technology. They can also use polarized glasses. It is very well possible, but usually in televisions it is seen that they use shutter 3D, and that 3D is not passive. Like these two are passive 3Ds, but this one is an active 3D. Active 3D means your glasses are going to do something. So that those glasses are like this. Usually they are boxy, and they have one shutter which is either closing this eye or it is moving in this direction, so it's closing this eye. So one of the two eyes are open at any time. When this is open, this is closed, and when this is open, that is closed. Okay, now This should happen properly, like when this eye is open, I should be seeing that image which was shot by this camera. And when this eye is open, means the shutter in front of this eye is open, I should be seeing that image which is shot by this camera, right? So this is done by synchronizing the TV and the glasses. So they are always in sync, and they have to be synchronized very well in order to achieve this kind of a thing. So the TV, when showing the image captured by this camera, it will send a signal, and so this shutter will open and that shutter will close. Okay, and then immediately after that, it will show the image captured by this camera. So it will send a signal, and then this, this shutter will open and this shutter will close. Okay, and it has to keep doing it. Now, what should be the frequency? Obviously, the frequency is 120 frames per second. So it's a very cutting edge technology, you can say. A lot of coordination is needed between the TV and the shutter glasses, and that's why. See, first of all, it is prone to a lot of error. Usually the glasses don't work, or something is problematic. And the second problem that is there is it is very costly, because it involves a lot of technology, so it's usually very costly. So these are the three ways in which you can achieve 3D. Now, one fun fact I'll let you know about shuttered glasses. You try to see through any glass, you will see that the intensity of light of the film has decreased to 50%. And you remove the glass and see, you will see that, okay, it is intense, but as soon as you see through a glass, the intensity will reduce. Now you might feel that, okay, the glasses are usually black and that's the reason why it is happening. No, that's not the case. You can turn off the glasses. When you turn off and you're looking through the glasses, then also the intensity is high. And when you turn them on, then that shutter thing has started, right? So half of the time the shutter is closing it, right? And that's why when the glasses are on, then the brightness of the screen, you can make it out. It is 50% the brightness that you would normally see. Okay. Now, what are the current trends? In cinema theaters and in TV, you can see 3D, but usually active 3D is used only in 3D TVs and not in cinemas, because active 3D is a little difficult to have, because screen and your glasses have to be in sync. Now imagine 150 people sitting in a cinema theater. You have to sync everybody's glasses with the screen. Now that will be a little difficult. Besides, those glasses are extremely costly. And let us say that you lose a couple of glasses, or somebody steps on the glasses, or glass breaks or something. It's going to be really difficult, and you cannot get the reimbursement so easily from the customer. There will be conflicts. So usually you won't do that. In an entertainment industry, you will never do that. So you use polarized glasses for polarized 3D in theaters. But in consumer market, that means when somebody is a consumer, somebody has bought a TV at home. So TVs can range up to any level of cost, and that is why it is very much possible for you to give 3D televisions. So this active 3D is given in television. Another thing is PlayStation. PlayStation also came up with this concept that let us say you're playing two-player game. So usually when two-player games are played, then the screen is split between one player and the other player. So one player is seeing their perspective on half of the screen, and the other player is seeing their perspective on the other part of the screen. Now this 3D technology came in PlayStation also, and PlayStation said, see, you just need persistence of vision, right? So I'll broadcast picture at the frequency of 120 frames per second, but 60 frames will be for player number one, so they'll be able to see, and it will be synchronized with the glasses. So both the glasses will open only during those 60 seconds. So although he is not seeing a 3D image, but he's seeing only his perspective, because both the shutters are open only during the first 60 frames. And in between, whatever the second set of 60 frames are there, for them, the other player's shutters will be open. Okay, so both of them will be able to see their perspective of the game on the same TV. So that is amazing, but of course it's very costly again, because you need synchronization and you need specialized glasses which are active. They usually have battery, and then that battery drains off very easily. I haven't seen any glasses which don't come with the battery or with rechargeable battery. I haven't seen till now. Usually it comes with that small little coin shaped battery. Okay, so that is how it is. And generally TV manufacturers now, so this is trends, right? So TV manufacturers are now moving away from 3D because quite frankly it's a costly technology, and no one is willing to see a 3D movie on television. If I have so much of money, maybe I'll go in the theater because that is an immersive experience. My neighbors are not shouting, the dogs are not barking. I don't have much of a disturbance. People are not honking their cars. So it's an immersive experience when I go in a movie theater. Besides, there is no excessive light coming through the windows, or somebody has put the light on, and that kind of thing is not there in a theater. So that's what is an immersive experience. So if I really want an immersive experience, and also the sound, how can you forget Dolby Digital or whatever? There are so many sounds, and in the movies, nowadays even the seats shake. They give you a feeling of shaking and all. Some theaters even have smells. Various smells come to you. Or some theaters have water showered on your faces during the movie. Like Elemental movie, it came in 4D. So what is 4D? 4D means this kind of an effect, that the seats are shaking, or water is being sprayed upon you and all. So for all this, you will go to the theater, right? You cannot have all this at your home. You cannot build a theater at home. And if I have money, why don't I go and have a nice cinematic experience with my family in the theater? I can go to a 4D theater. I can very well do that instead of putting curtains and soundproofing my room, and then having various these sound boxes at various places in the room, and then sitting right at the center of the room and then seeing the television. No one goes through all that pain usually, and that's why nowadays 3D televisions are not in the trend, and gradually all the manufacturers are moving away from them. Animated movies are usually having a 3D version as compared to normal movies. Why? Because animated movies are usually having virtual camera. The entire movie is shot or individualized inside a computer. Okay, you just have a program like Maya which is creating 3D characters, and then you have some other program which is called as the game engine, in which there is physics and everything, and you make things happen. And even this is a very old thing. Probably nowadays they don't even do this. This is just computer generated imagery, that is CGI. So computer just thinks about it. And sometimes characters are played by real characters, and the film is shot, and they on their dresses they have various markers pointed there, and in the post production those markers are understood by the computer, and it creates an animated character in place of that real character. And in the real movie you see only that animated character. You don't see the real people who have shot that particular film and who are there, who are the real characters in the film. You don't see that. So everything is animated, everything is imaginary, everything is running in the computer software. So since everything is running through the computer software, now you can ask the computer software that instead of having one camera, have two different cameras which are a little apart from each other, just like the eyes of a human being, and you shoot the movie like that. And then while showing the movie, you'll be showing this footage for 60 frames per second, and this by 60 frames per second, so total 120 frames per second will be shown. And then we'll be using polarized glass to view that particular movie. So animated movies are very easy as compared to other non-animated movies. For non-animated movies you need a physical camera with two lenses, and it is very costly as compared to a normal camera. But in animated movies it's pretty easy. Instead of shooting it through one perspective, you can shoot it through two different perspectives. You just have to program it in that way, or you just have to tell the software that there have to be two different cameras, because camera is virtual. Okay, so that is all. I think I just wanted to give you a complete perspective of what is 3D, what are the various types of 3D, and how they all work. If you still have any doubts, then please ask me in the comment section. I answer to the first 100 comments always. And until next time, this is Amit signing off. Jai Shri Ram. Thank you so much for seeing the video till the end. It does mean a lot to me. Could you also please see the video description? It has index, link to the study material, and also if I've shown any products in this video, then the purchase links to those products. The comment section is open for your suggestions and also for your doubts. I always answer to the first 100 comments on every single video. If you want to support my work, here's my QR code or my UPI ID is amit.shirasao@UPI. Until next time, this is Amit signing off. Jai Shri Ram.